Okay, this is the second video on angles in a circle at National 5 level. I picked out 3 past paper questions that I'll do just to show you the idea of what you do for these type of questions. Now they come up every year, they're always worth 3 marks, and there's about 3 or 4 properties that you have to know about. Okay, hopefully you watched the first video. The first video just went into all the properties and the things you have to know about a circle at National 5 level. But for this particular batch of questions, things you have to know about, the tangent line. So you need to have done that before you can tackle this question. Tangent line, that's a line that just touches the circle at one point. And isosceles triangles within a circle. This is an isosceles triangle. Radius here, so that means that angle is going to be the same. So that's going to be helpful when we come to that, do that question. I think this should say 58 in here, so let me put 58 in. 58. Second question here, well, we've got a tangent line again, so there that's come up again. And the property you have to know for in here, for this type of question, is triangles that make within a circle that have the hypotenuse as the diameter. So this is the diameter of the circle, and we have a triangle coming off that meets in the circumference. That tells us something special about that. We'll talk about that when we come to this question. Same idea here. And the last question, well, that's all to do with tangent line again, isosceles triangles. So you can see the properties that we have to use here. Isosceles triangles, right angle triangles, and tangent. Very, very common. And look, the tangent line appears in every single one of them. So these are the properties you have to be aware of when you tackle these questions. So let's tackle the first one. First question says, calculate the angle CAB. So CAB, that's that angle there. So you have to know what that is, CAB. So we have to find out what that angle is going to be. Well, we're only given 58, that's all we know there. So there must be properties that you need to spring into your head. So tangent line, so that tells you this is 90 degrees. So that's 90 degrees there. Okay. And the other side must be 90 degrees. So if I've got 90 degrees on this side and this is 58, 90 minus 58 gives me 32. Let me just double check that. 90 minus 58 equals 32. So that's 32 goes in here. Now we've got an isosceles triangle, so that must be 32 as well. And if we add these two up from first year, angles in this triangle add up to 180. So add these two together. So 32 plus another 32, 64. Take that away from 180. And that gives me 116. So this angle in here must be 116. So using a straight line theory, so the straight line adds up to 180. So 180 minus 116 gives me 64. This angle in here. Now, people who are switched on, it is true to say that these two angles here must add up to the same as this angle here. But if you're not sure about that, you just work it all out. So we can now work this out. This is the angle that we're trying to find. 90, 64, add them together and take away from 180 gives me the angle that we're looking for. So 90 plus 64, well, that's going to give me 154. And take that away from 180, so 180 minus 156, sorry, 154 gives me 26. So that 26 degrees. So that angle is 26 degrees. Finished. Now that question is worth 3 marks. These questions are always worth 3 marks, so that'll be 3 marks, 3 marks, and 3 marks. And you can see all to do with a triangle, a couple of wee basic properties, tangent line, angles in a triangle, isosceles. That's all we had to know. Right, the second one. This one here. So we're asked to work out PQR. Right, I think I missed a wee angle in here. I think this is meant to be 37. Let's put that in. So well, given this diagram, we have to work out PQR, which is this angle here. Well, it's actually two angles added together. This whole angle here. PQR. PQR. So, tangent line again. Well, that whole angle there must be 90 degrees. The other side must be 90 degrees. Remember, tangent line. And the radius. Here's the radius line. Perpendicular, so that must be 90 degrees, 90 degrees. So this wee bit in here is going to be 90 minus 68, which is 22. So that's going to be 22 in here. Right, the next property. This triangle here has the hypotenuse, it's the diameter. So you've got to know, that's a property you learned in the topic, that's 90 degrees. And the same here, because this is a diameter and it's the hypotenuse of the triangle that meets on the circumference, this is 90. So we're nearly there. Let's work out this triangle and get this wee angle in here. So to get that value, it's 90 plus 37, that gives me 127. And we take that away from 180, so that's 180 minus 127, 53 I think, 53 that comes to. So this angle in here is 53 degrees. And do the same for the other triangle, so we've got 90 plus 22, it's 112. 112, take that away from 180 to find the missing angle. 68 I think, my maths is right, 68, so that's 68 in here, nearly finished, last wee bit. Well, PQR, it's those two angles added together, so 53 plus 68, final answer 11 and 1, 121 degrees. That's my final answer. Again, worth 3 marks. 3 marks in the exam. The final question, this one here. We have to find this angle in here. Now we're only given one angle, so if you only find one, if you've only got one angle here, then it must be to do with properties, lots of properties. Well, here's a isosceles triangle in here. So that angle and that, sorry, that length and that length are the same, so this angle here, this angle must be 28. Now, this is a tangent line here, a tangent line. So that tells me that this whole angle here must be 90 degrees. Now, this angle up here, we can calculate that, so that's going to be 28 plus another 28, which is 56 degrees. Take that away from 180, 56 minus from 180 gives me 124 degrees. So this is 124 degrees. That's that angle there. So the other side, straight line, so it's 180 minus 124, that's 56. Again, people who are switched on with angles, it is true to say that this angle in here must be these two added together. So that gives me 56. Now, we could calculate these angles and go a long-winded way, but the quick way of doing it, hopefully you can see this big triangle here. This big triangle. We've got two of the angles, this is 90 and 56. So add these two together to get me from 180, gives you what this angle is, and that's what we want to find out. So 90 plus 56 gives me, that's a 146. Now take that away from 180, minus 146, will leave me, that'll be a 34 degrees. So this angle in here is 34 degrees, and that's what we're asked. Okay, 34 degrees. Always put in any angles you calculate, always put them in your diagram. Okay, so whatever you're working out, we worked this one out, we worked that out, put it in your diagram. The examiners like that, and you quickly get the marks, you can build up the marks. So where does the marks come in? Well, if you know a tangent line is 90 degrees, that's usually a mark. Certainly to know that this is 90 degrees in the second question would be a mark. Isosceles triangles are always asked for, and angles add in a triangle add up to 180, all that type of thing. Now they're all worth 3 marks. That's a 3 marker, 3 marker, 3 marker, and it comes up every single year. So I would encourage you, quite an easy question if you practice it. Okay. Right, the next video that I'll do is on Pythagoras within a circle. I'll do that and get it posted to you. For this type, if you're looking for more practice in this, and there's loads of practice every single year, so look at all the past papers. You get all the past papers on mathsrevision.com. Okay, that's it.